while exploring innovative teaching methodologies and incorporating technology as a learning tool. So, ladies and gentlemen, please join me in giving a warm virtual welcome and applause to Mr. Stephen C. Capelitan.
Good morning, everyone. My
Good morning,
buntag.
sir.
Uh, it has been a long time
Good morning
since
po.
I was able to catch up in inside the campus because for those who don't know me, I am Steven. I'm currently here in Makati. I'm also a PhD student in Lasal. I'm all my way in my dissertation, and what I would like to present to you for this webinar would be my a part of my dissertation, because this is a work in progress. So we're given a chance to I'm given the opportunity to seek um, different educators from all over the country, because this topic is not new. Okay, this is an emerging field which is not being popularized in the Philippines. So I also have like to give this opportunity to Ma'am Munera and her class, because they were able to seek me. Hindi naman ako, I'm not that really stayed long in education. I started my education in I graduated 2016 in MSU IIT, and I'm a proud alumnus. So yeah, so everything was seemingly possible because we're doing it online. So this is not a new technology to us. It's since the previous speaker was already mentioning about how could we elevate our experience as educators, as teachers in this era. We're now in hybrid mode, especially in handling. I currently handling microbiology and cell and molecular biology in PLM. So this is kind of mixture of students that I'm handling right now. So allow me to share my screen. Okay, so when you see this is okay. There is a QR code that is being placed in the screen. I would like you guys to scan this QR code first, so that I could, get something from the educators all over the country. This is more likely I can give to you the links later, but if you can do it now, you can just screenshot. Well, I couldn't really provide the slides because again, this is like an intellectual property, but you can screencast all the videos, all the slides that I'm presenting, because I'm still working on it. Maybe there are some changes on the projects that I'm currently doing right now. So this is just the first uh the QR code. Sige, I'll just move on with the next slide. So dealing with right now, since our classes in PLM will start this week. Okay, and I have not yet met my cell and molecular biology students because I'm handling lecture. So their classes are hybrid. It will be both online and on-site class, with the modality that I mean, especially in Metro Manila, where students are really like avoiding the traffic, and also with the faculty members. So conveniently, we could meet sometimes online and cell and molecular biology, because as what this Siddhartha Mukherjee, an author that like he was publishing some books like The Song of the Cell and Exploration of Medicine and the New Human. It really inspires me to point where we are in the era and age that all of us are acquainted with different technologies, what we mentioned earlier. But this time we are now behaving in such a way that even though there's an existence of these latest technologies, we current keep updated and how to solve big problems and complex problems that we're facing. So we're learning on how to transplant cells back into the body. We're using genetic engineering. It gives us a new level of dimension that we never did before. Okay. So in this book, laymanized version of what cell biology is, the cells in medicine, it really gives us the idea where we can really merge, okay, our learnings in cell biology and medicine and vice versa, because that's what our students lack, lack the meaning making process. They study, they go in the field, let's say they go in dentistry, they go in medical technology, nursing, pharmacy, all of that. But whenever they are inside their program courses, they were really not sure about what's happening outside. They were really sure if the employment that they got in the future would really find meaning making in inside the classroom. So this is what the Song of the Cell is all about. Oh, a renowned book from the New York Times. If you have time to read the book, I suggest you to read it. So there's of course, as a teacher, we always have to do this. Like, we reinforce our students at the very start of our classes. Okay, I need the attention of everyone. There's a photo on your left and on your right. Would What do you think are these photos? And how are they connected? Anyone? Okay, okay, okay. So, okay, I'll explain the photo. Yeah, there's a photo on your left side and there's a photo on your right side. The left side and the right side. So, what is the connection between these two photos? Or if you don't find the connection, what are these photos? Any wild guesses? Okay. I'm seeing the comments. White blood cell and the wound, blood clot on the right side. Okay. Left blood lump, then blood at the right. Okay. Death. Okay. Blood clot. Mhm. Supernova. Okay. I've seen here opposites of each other. Cells. Okay. Thank you so much. Macroscopic and microscopic level. Okay, let's look upon that. Thank you for your answers. Okay, that's great. When you see the photo on your left and you see the photo on your right, okay, of course, that's a blood, the redness of your blood. And then on your left is technically a death of a star. It's a supernova. But before we move on that, we would like to see how this image how this character um, is being known for his extraterrestrial powers in Marvel Comics. I'm a huge Marvel fan, I I am really fascinated with how the comics and all of these fictional characters work. So it makes us, I mean, even though I'm a science teacher, I could also become acquainted with different, of course, we have hobbies, we have interests. So this one is, as much as I love the space and the extraterrestrial beings, I am also a fan of reading books like this. So that's why in my field, I tried to connect everything from space and from the microscopic level, as what your answers were telling me before. So this is a supernova in a human blood. Going back, um, can you see the connection? Can you visualize what's the connection between the two or interpret? Yeah, I am Groot. Yes. So the photo on the left represents what we see under the microscope. The other is what we see with our naked eye. No, this one is being viewed like this is just I don't think if it's captured by a satellite, but I think this on your right side, the human body photo, a camera. Yeah, it signifies death. Okay, so let me tell you about this. We of elements and all the elements on the periodic table, from hydrogen to the transition metals and the halogens and all of that, is a product of a supernova, okay, or a product of the death of a star. So the stars typically does this billion years, and relating the blood, okay, relating the blood, the color of your blood is red, and the element that makes it red is iron, and iron is a component of your hemoglobin, which is a protein molecule, and that's the connection. Although it's too far, if students nowadays can see meanings or and how to we could really achieve whatever learning that they could anticipate or they could learn inside the classroom. And, and with this, okay, since we're learning more of cell biology, this is more of like a fictional, I mean, more on literature level kasi it was being shown in the screens before if you're fond of reading books and movies and films. This was The Fault in Our Stars. It says here that the main characters of the story has cancer, and once there is a fault in the stars or there's a fault in our stars, okay, the elements that are found there is of course the DNA at your level, cancer might arise, mutations, okay, this tumorigenesis, all of these things were, I mean, it disrupt, and we can't really find answers for now because our work in medicine are still in progress regarding to combating or eliminating cancer, eradicating it. So a lot of typical news that we found in everywhere, social media, would take a look at the different products. Okay, I've heard recently that the Coke Zero, I sorry, the 0 calorie drinks, soft drinks, beverages, they were being pulled out by the FDA because they're potential carcinogenics, and we didn't know that. Okay, potential carcinogenics. So there's also a study done by Harvard Health Publishing and Harvard Medical School. You see a protein powder. Okay, weightlifters and gym enthusiasts use these protein powders. Okay, as a biology teacher, my initial reaction to this everyday biology, such as these nutritional products or even medications, is to wonder how it works. Of course, we would like to know how it assimilates, how it is being absorbed by the villas in our intestines, and how it is being absorbed by the blood vessels, carried out the different organs of your body and all of that. However, the non-biologists think around me and often ask it what it is for or what is it for, diba? So this could be differing, this idea could be differing our epistemologic beliefs of biology, and they were being shaped in education. How we view things as a teacher, as a student, and as a non-biology major would differ. What is it for or what it is for? So technically, it's not really that meaningful for us teachers, but for the students, it's like they really don't have they don't give a damn thing about it. Okay. So that's the hidden dangers of we don't really know the hidden dangers, but there are a lot of published um papers about this one. So we move on with the topic. It's integrating the biological the taxonomy of biological understanding via stack and flow diagrams through stellar architecture for enhancing our perceptions of systems thinking in learning cell and molecular biology. So I'm Steven, and again, this is a work in progress. I'm still working on it. This will be implemented. Not yet. presented this one to my panel and even to my advisor. But since I have really started this project a year before, I have like experimenting my students for those who are teaching, I mean majoring in biology, teaching biology, undergraduate students. I've let them experience what a systems thinking uh learning or concept because I guess the fundamental problem in our education is that, especially in biology education, they're often swimming in a sea of meaninglessness. And one of the problems in biology, that's why a lot of math majors, engineers, and the humanities majors, they don't like biology because it's a lot of rote memorization. There's a lot of rote learning that's happening here. We need to define, we need to memorize these terms, and at the end of the day, they don't find meaning at all. Okay, so in this biological understanding, we need to find ways on how do we incorporate systems thinking in cell and molecular biology. Let's give it just a breather because this is a lot uh, a sensible topic. We need to learn a lot of terms here because this is a new dimension. Okay, so we see here photos. Um, this one on your top left is a brain, neural circuits, is a weather forecasting. This one is an IT computer, and this one is an island, an ecosystem. So these four photos define a system. Okay, and as we further progress with that, again, this is generally understanding what the most significant influences on the student are, how they interact, okay, how they relate in a given situation. So most student problems are system problems. Do you believe in this? Do you have any reactions that our student problems are system problems? Yes, 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 sorry. Okay, thank you. Do you believe that it's a system problem? And it doesn't, yeah, I thank you for your answers. It doesn't really mean that when students are facing problems in the classroom, it is an effect or a domino effect from what the previous generation and the future generation are acting upon it. Because not just teachers, not just the administrators, not just the government, but since we are being shaped by our system, this is a cascading effects. We need to identify what are these problems, but if they are not being properly addressed in the classroom, then problems might arise. And problems, okay, are 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 a subtle way of telling us that we need to innovate. Okay, that's why we are having this webinar. We are enhancing. We are technically what MSO IIT is telling us, influencing the future. Okay, we become we became innovative, and in such a way that we're trying to solve problems, but that solution isn't really the only solution. Okay, but we're trying to. Okay, I guess that's the whole point here. So we need to specify the problems. We need to construct the hypothesis. We need to test the hypothesis. We have to complement changes, communicate understanding, and we have to specify the problem or issue. And this is typically one of the most prevalent ideas that every science teacher know, the scientific method. And we understood that the scientific method is just a linear path and how do we solve problems. We're incorporating this in our research. Okay, we teach research, we teach thesis, dissertations, but we haven't realized that instead of a okay, linear process, it could be a circular process. Where circular process, when we can't meet the hypothesis, you go to specify the problem or issue. Okay, and that's what the systems thinking is all about. Next slide. Extensive boundary and the intensive boundary. Okay, this is quite difficult graph to talk about. Okay, this figure is the extensive and intensive models. In the extensive boundary, we should know what to include. Okay, what are the essentials? Should the students know about this, or should the teacher talk about cancer alone? Does he or she need to introduce to them what cell division is, or what pathogenesis is, and all of that? So the extensive boundary is what to include. The intensive boundary, how detailed it should be. Okay. So there is a research done by Moore, and when teaching genetics, we're often given the idea that when we hear genetics, the most profound way of teaching is molecular in a molecular level. Okay, we started the introduction to to genetics. Next is the biochemistry of life. I know I don't know I am a bookish person. That's why I can really visualize what's intended in the textbook and what's being taught in the classroom, because DepEd has compressed the curriculum from the K to 12. They made it K to 10, just to address the vastness of learning that they did, or our students are learning inside the classroom. So going back, so we started with molecular. Diba, in anatomy, we started it with an introduction, and then the biochemistry starts with the cells, then tissues, then the organs and organ systems. And then we focus on different organ systems, and then the pathogenesis that relies upon each of the organ system. So in the intensive boundary, we should understand that um our curriculum is cruel. Okay, sometimes there are some portions in the curriculum, like the topics or chapters that are found on the last portion of the book will not be covered, especially evolution, especially ecological perspectives of everything. So I don't know if you're seeing the point, but the teachers is having a difficult time to to finish all these lessons. Okay, they can't reach to the point where we don't know that the last portion of the book will be the most important one. But we did not finish it because we're running out of time. Do you agree? Yeah, they agree, yes. And yeah, so here, okay, what I'm proposing now is we need to elicit and articulate mental models that will impact the social and the organizational structure. We should creating or expanding our mental models, test and improve these models via simulation, develop shared mental models to more effective organizations. Well, this is being used in business. The idea of systems thinking started in business. The uh, 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 um, the he was like telling us that one of the most important thing, okay, if you can think it, you can model it. So he was a fan of systems thinking. So this systems thinking and systems dynamics is is not being offered a course here in the Philippines. One of the most renowned MIT. Okay, so um, with these tools or the systems thinking foundation, we need to classify these three terms. Structure generates behavior. Okay. Mental models matter a lot, and the fundal attribution error. Sige, let's talk about what a mental model is. How would you understand the mental model is a set of assumptions that is a group of people structure our classroom. Like we have LMS, right? It could be Canvas in structure, could it be Schoology, Moodle, blah, already know how to use it. It makes us exemplary teachers, or it makes the institution an exemplary one if we're able to make use of LMS. But it's not just the physical structure, it's not just the information and the incentives. It is um about shaping, okay, how classroom activities are to be designed, even though we are following the DepEd mandate in the K-12 curriculum. Teachers would it would be a, a tough job for thinking models, but it is not just um not just for all, okay? Because if you're interested in the other side of the pedagogy of the students, then go for it. Okay. Again, this is not a solution to fix the problem. It's just one of the solution. So our first instinct is to blame the people in the system. Almost always a low average response. Of course, it's really true. Okay. Um, we blame the teachers, we blame the classroom, we blame the parents. Okay. Who else to blame? Okay. This is the fundamental attribution error that we do always. So when we introduce the subject to our students, tell them that it is not just limited to biology. Tell them that it's not limited to what do you call this one? Medicine. Like how could they practice themselves becoming our future scientists when in the basic education level they weren't introduced with such complicated topics? Are we afraid that it might backlash us that our students will tell that we're setting too much or high expectations? I guess no, because from what the previous they call world rankings from our students that we're doing this always, like we're doing the basics, we're doing the most easiest tasks for our students. They can't really compete internationally, and that's alarming. Okay, it's alarming not just for the Philippines, but for our our future students as well. So this is a curriculum. Okay, there's a curriculum A and a curriculum B. Which do you think is better in teaching biology or cell? Yeah, in general, biology. Which do you think is better? Can you type in the chat box? Is it A or is it B? Mm-hmm. It's A. Where is it post? Yeah, it's B. Thank- Mhm. Okay, sige. I'll explain this to everyone. A because it's specific. Thank you. Mhm. So now we progress with the curriculum. We can't just change the curriculum, especially the ones being provided to us by DepEd. These were critically planned and assessed by um, developers, administrators, even legal bodies. Okay. But what I suggest here is that even though we're teaching in a spiral curriculum, or the progression of our courses in college, okay, especially in college, because I've been teaching in college for almost 4 years, and I find it easier to teach in college because you were just asked to um deliver the lessons from start to finish, from a book, okay, technically from a book. So in the curriculum, this is the most traditional one. We started with the animal cell, the plant cell, and then specialized animal cells, and then we go with the systems. On the curriculum A, um, we are like doing, as what I said earlier, the phenotypes and the phenotypes versus the molecular entities. We're doing it yo-yo in the yo-yo approach. That means when you discuss the muscle cells, you will discuss also the organelles because the kids are quite confused with a muscle cell, okay, versus a typical animal cell. There are some terms in the muscle cell like sarcoplasmic reticulum that they don't really relate on the typical animal cell. Where these things come from? Enterocytes. Sir, are they types of cells? Yes. But where are they found? They're found in the digestive system. Ciliated cells. Where can they be found? Respiratory system. Kasi when you focus on the respiratory system, if I teach anatomy and physiology, we typically go and jump with the collective parts of the anatomy, the upper respiratory tract, the lower parts, and then all of the intersecting parts. We typically, yeah, um we don't really touch more of the molecular part when we go into systems because we're done with that in the cells introduction and in the tissues part. Do you know what I mean? So instead of instead of like having it a progressive way, we can do it like it teach muscle cells and their organelles, like nervous systems and the neurons, okay, the palisade cells and their organelles, and the plants, root hair cells and their organelles. So this, I'm seeing this from Christian Moore's um, figure. It says here the level of abstraction, and when he did this in his classroom. By the way, Christian Moore is a science biology teacher, science teacher in the UK. I have talked to him using X or Twitter, and I'm really fascinated in how he is doing this biological understanding and its taxonomy into teaching biology. So we're much focused on we have here population, organismal, cellular, and molecular. As you go further down, the level of abstraction is becoming negative, and as you go progresses up, the more it is, um, positive. The difficult ones are found in the molecular level. Okay, that's why a lot of my students, let's say, for example, they are dentistry students that are progressing to med school, or sometimes, yeah, DMDs, or my biology students who are progressing to med school, even med school students, irregardless of the institution, they really find biochemistry is really hard subject because they were not acquainted with the molecular stuff. Okay, biochemistry, one of the most difficult subject in the first year med school. So here, the level of abstraction, we go focus on the organism because that's what we understand, right? That's what um be an organism. We are making up of an organism. So here, uh, a meaningful biology pala. Okay, a meaningful biology relates principally to organisms. Sometimes they can see the school fair, science fairs being irrelevant or not interesting to them because their perception of it is what makes it a reality. How can I use this antimicrobial whatsoever plant to cure this or to eliminate this type of traits of bacterium. They don't have or they lack awareness, okay, between their science activities and the world around them. They're they're searching meaning, especially during the pandemic where when the rollout of vaccines, it is, it is a thing that some of the non-vaccine goers might believe that this is just like a hoax or this is like a kind of a conspiracy theory. Okay. So they don't see the point. They don't really see the point. And as a part of the solution of these problems is to conceive what are the goals of the science education. Okay. We need to understand events, whether it could be molecular or population level. We need to understand that we can restrict ourselves in learning the molecular and cellular alone. How could they relate it doing it when they come or when they are in an organismal level? Do you agree? And meaning making, as what Christian is telling in his book, meaning is in our immediate world, not in the correct answers. Do you agree? Even though they got a good score in your examination, would you think that these students can accelerate or can, give much of a contribution to our country in this field of science? If you know Alexander von Humboldt, he told us that to understand the world, okay, a scientist has to be in nature. Knowledge couldn't be gained from books alone. Knowledge couldn't be gained in the classroom alone. Whether your classroom is just, you know, a bare classroom or the one that is full of materials, education materials, it really depends on the learner. It really depends on the system that creates the learner, that shape the learner. So there's a lot of things here that's this graph or this figure is really telling me, diba? Especially if we teach genetics, meaning a student could really indulge in the lesson if it talks about his or her identity, his or her origins and landscapes. Being a Filipino, okay, being here in the Philippines, how could you relate evolution in the context of the Philippines? That's why when doing my master's thesis, I did citizenship science, because I believe that a certain problem in a community or a region could really address biodiversity issues. And when I did focus on the problems in each of the provinces of the Philippines um, facing, people here in Metro Manila, students here in Metro Manila don't really our students in sciences to be more to make meaning making in the classroom. Like this one, lessons and this lesson. On this right side, you have here systems, cells, and organelles. On the right side, uh, I shaded it here, 1, 2, 3, 4, 5, and 6. So you can talk about systems and cells in one lesson, concepts of organelles and cells in the other lesson, and you can yo-yo it actually. You can phenotype, molecular phenotype. And I've made clinical case studies. Well, this is a part of my topic of my research. The clinical case studies are designed in every chapter of the book, especially in cell and molecular biology. So my participants are this. Three of them were coming from, three sections are coming from the cell and molecular biology, 26 each of the section. And then there's another one, genetics laboratory, and then they are like 16 of them, and then they are education majors. So these three concepts, clinical case studies, system dynamics modeling, and system thinking is the one that I will be measuring after introducing this um, intervention Okay, how could they become more of a systems thinking modeler than the traditional one? So we're seeing here the different perspectives of integration of the organism. We will just not see how organism works. We could see its evolutionary, ecological, and their contemporary. So on presenting the topic or the lesson, diba, we typically have the uh, the 7 E's. When introducing the lesson plan, I mean, we could we could actually become more acquainted with this type of approach. Okay. Moore and Anderson 2021 promotes this integration of the organism. How is it being evolving in the population? What is its meaning for its organism and the environment? And have the students make predictions. So the bluer part here, you can see this portion, is the one that is most important. Associate and separate. They should know how to associate and to separate parts. Clump, disorganize. I'm sorry, connect, disconnect. So that's the thing in this framework. And in understanding systems, we should understand what are the primal wholes and the proximal wholes. It means that not all the systems are big. A cell can be a system. A mitochondria can be a system. Diba? So we call the mitochondria as a primal whole, and then we call the parts of the mitochondria as the proximal wholes. Let's say the mitochondria has cis the cisternae, okay, or the Golgi bodies has trans and the cis portions. We can actually make use of proximal holes and the primal holes in the context. Or let's say, for example, the primal hole is the cardiovascular system. The proximal holes are the blood vessels, veins in the arteries. And you can make use of this term, okay, as you further progress with your lesson. So this one is an example. The topic is the relationship of stem cells and the organism. Typically, we don't teach ano lang, we just teach the stem cells, diba? Not the organism. How is it being relevant? I dissected it to different portions. There's a content, there's a critical aspect, there is a contrast. The contrast is how would you differentiate specialized cell types versus simple multicellular organisms without specialization. There's a hypothetical situation that is going on here. We are making the what if type of questions. What if specialized cells divided and regenerated tissues instead of stem cells? What will happen? Okay, you're presenting a problem to your student that will not happen. But if they answered it correctly, that would, you know, give them the avenue to dig deeper into the problem. Mammalian adult stem cells with plant meristems, of course, because they're much more focused on what an adult stem cell is. How could you relate it to a meristem in plants? That's the first topic or an example. The second one is the cell principle. As we go with the contrast part, um, spontaneous generation versus the cell principle. Okay, sikat si spontaneous generation in microbiology. Okay, um, from Brandeis experimentation, diba? And then the cell principle was acquainted and being introduced to us by Virchow, Clyden, and Swan. These two ideas from scientists were sometimes, you know, they have their strengths and weaknesses, but how could we able to contrast it? We don't usually do this in class. Different scientists have different perspectives. Lamarckian, Darwinian, okay, or Wallace's and Darwinian. How historically these are true, but they don't find meaning with it. maraming scientists, we introduced them in the first part of our class. These are the scientists that are shaping the golden age of microbiology, but we don't usually introduce them and their significant contribution against each other, or how could they be connected to it. What else? Um, in integrate part, why did air sacs evolve in dinosaurs? Okay. Why? What does it mean for all the way of a large organism such as the elephant to maintain many cells compared to a smaller organism? Why does you're just you're asking like, why is it there is a multicellular organism than unicellular, where you can't make multicellular just unicellular or vice versa? That's the cell principle. So in this figure, this is the taxonomy of biological understanding. Uh, Christian Moore created this pattern where as you go more on the upper part, there is an emphasis on function. On the lower part, the y-axis, the emphasis is more on the mechanism. On your going to the left is more on fragmented, and on the right is network. So the more network knowledge, the more mechanism, the more meaningful and explanatory it is. The more function and the more fragmented, the more rote and descriptive it is. Actually, this is the least. Yung mga questions like, what is the powerhouse of the cell? This is more of the rote and descriptive. More on the meaningful and explanatory, there's a what if type of questions that lies within it. Okay. So what and in the questions, what and why, and then the what for, okay, how and what if. So I'll discuss this one later. And this is just the overall arcing principles of a typical biology curriculum. So we want in this portion, we want the zone of developing systems thinking portion. The sorry, the zones found in this this is color blue all in all. Typically these two portions on the curriculum, on top of the systems thinking and below the novice knowledge, these are more commonly seen in schools, especially when Christian studied this part. he he is referring to the schools in London and UK. This is not yet implemented in the country as what I've said, but this is what also I'm yearning for. This is what I'm expecting, that we are more likely doing in the zones of this general curriculum. So what would happen if? This is the entire question. So explaining how the performance, the whole could be affected, and then on the systemic part, how the parts interact causatively. Uh, Hindi lang dapat, it is just not we understand the whole, but we could also understand the parts. Okay? As I said, it's not a reductionist and alone, but also a holistic approach. So we can do a vis-a-vis. Okay? We can do it two-way. So describing how the parts do, what the parts do, but how do these parts interact causatively. I'll give you some of the sample questions. So what is it? Okay, this is a very simple Sankey diagram. Bakit may Sankey diagram? Sankey diagram is this is the flow of energy over time in a system. So meron tayong power input of 100 watts. And then how do we define it? Kasi there's a useful input of 20 watts and then wasted water power input, which is 80 watts. So a total of 100 watts. A Sankey diagram looks like this: the flow of energy over time in a system. So this is an example, simple stock and flow diagrams. So now we're doing modeling. Okay, we're modeling now. How could it be related to the idea before? Well, systems thinking is not just an essay type of like answering questions. Like what if like this? Before you can derive or actually go on with the answer, or even though if you get the answer, you should be able to model it. Modeling it in such a way that you can manipulate all the variables in it. Okay. Although difficult chow in our setup, like in public schools where they don't have the luxury of like time to make use of a computer, but actually they can make diagrams. These are just like complicated concept maps. But these concept maps can be adjusted. Like you can see here the two triangles of water flowing in and water flowing out. It is like a an adjustment. Okay, you can adjust the grid, and then the water will stay in the bathtub. When you adjust this portion, the water flowing out, then the water will exit the bathtub. So the blue triangles will represent the taps that they can be regulated, and then the plugs are also a way of regulating the output of water. So there, the water in the bathtub, it has a positive or same as you move the water flowing out. So when you increase this water flowing out, it has a positive effect on, sorry, the movement of water outside the system. So we refer this water in the bathtub as the stocks. These are the stocks that we are looking. Kaya nga stock and flow diagram. There's a flow and there's a stock. The stock is the water. And if we kind of make use of uh, qualitative ones, there are numbers. I hope that we are not afraid of numbers. 100 ml water in the bathtub will have the same effect as you move the water, okay, with this times 0.01 is equals 0.01 movement, rate of movement, milliliters per second. So they can adjust, they can assign figures or numbers into this diagram just to picture out how it will be looking like when we apply the model using computers. So there is a same effect on the urinating and opposite effect on the drinking when we introduce this one as the water homeostasis in the body. So look at this. Teachers should have been very creative, logical on how could they incorporate, wala naman silang bathtub sa bahay, but they could picture out what a bathtub is in science, in learning biology. Look at this. Water in the bathtub is the same as the water homeostasis in your body. We're drinking, okay, has the opposite effect, and then urinating has the positive effect on the water in your body. Homeostasis. Another example is how feedback loops maintain, the glucose in the intestine, the blood, and in tissues with insulin that has acting upon it. You see the red, it has uh the red arrows introduce or depict negative feedback. The blue one and the green ones are the positive ones. The orange arrows are there for like the flow of your blood. So generally this one, the students can also design and can make this one using paper and pen. Okay, just let them introduce a topic, choose them. I will explain to you back on how they could choose a topic. And there you go. They can make models like this and something like this, variation in the population. Okay, mutation, sexual reproduction, selection. Sorry if I'm making too fast. Then allele diversity in the population. So there is a gene flow acting upon it, and there's a population size. Then they could really use the models. Um, the entire video of creating this is being posted on YouTube. So I have a YouTube channel. So if you wish to subscribe, I can give you the link afterwards. If you want to make systems dynamics modeling in your classroom, there's a primer there. I've used a chicken versus chicken zombies. Okay, what if the chicken will become zombies in the future? How could you eradicate these chicken zombies? So I'm using a Stella architecture, a software in the computer. It's for free, don't worry, but you can just make a limited models out of it. But if you can't really introduce the systems dynamics modeling in the classroom, I highly suggest that you can make out of this. You can just make this paper and pen diagrams. Okay, so that questions like this: what would happen if the rib cage were fused and couldn't move? What would happen to the nutrient cycling of a stable landscape if it was suddenly deforested? What happens in a reflex action? And what would happen if the synapses were 3 times wider than the normal? And lastly, what would happen if a person suddenly had 50% less red blood cells? Difficult, basic, we are acquainted with it. As you go down the iceberg model, the more systemic mental models we create, the more um, meaning making we are uh, getting in touch, or we are getting from our students. These are the case studies that I created for the cell and molecular biology. Um, Starting from the introduction, yeah, will the common cold be cured by antibiotics? In every problem, in every case study, there are only three questions, 3 to 4, maximum is 4, yeah. So it just depicts the relevance of studying the cell biology in the clinic, or in human perspective. Problem siya, it will not cover the entire chapter, but somehow if the students could have grasped the concept or the questions in these case studies, it would fill their understanding for the entire concept or chapter. Because you can't teach all the main contents of that chapter. It would be time consuming, and it will be tedious for the teacher. So here is the one that I created. Para masyado lang siyang compressed. We're not making like the entire chemical basis of life. No, that's staggered lang. Up until immunity, cancer, cell division, signal, and all of these are coming from Karp's book, yung concepts. Okay, but these are subject to validation. It will be validated. I'm still wondering if I could use of course a science education PhD holder. I'm thinking also of a medical doctor to validate the questions. If this is really type of questions that they're using in med school, I still don't have an idea. But yeah, I'm still asking if how could we do that. So to extent of these are just the last portions. The extent and the scope and size of the core questions, it will explain to us that um as you go further from this dark blue portion, the optimal scope until explanatory power, okay, we when we ask students, and if they can, if the teacher can flip yo-yo the questions phenotypically and genotypically, vice versa, that is much more we need in these core questions that we will design, okay? Rather than when we atomize the questions, like, for example, what's the function of hemoglobin in your body? That is more of like the students will memorize it, okay? Uh, I, 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 I understand that you're not seeing the point for now, but as you atomize the questions and atomize the problems, it will become a rote memorization for our students. And the optimal range, or the size of chunk, okay, sometimes hindi tayo umaabot dun sa the breadth or the wide array of questions that we would like to raise in the classroom. Asking a good question is better than a correct answer. Okay. So when we are learning to address these questions properly and ask the questions properly, then we are able to make systems thinking on its way. And this is just an example of a problem. It is called as lesson. It must be a chemical reflex, subject or a lesson in hormones and endocrinology. So the first is you will be creating a model of a hormone system. You will research on how hormone regulates homeostasis using a negative feedback loop. You will use a Stella software. Ayan, you can see search Stella software. The model should be appealing and contain a plenty of background information to understand the dynamics of your hormonal system being modeled. And there's a lot of topic choices actually that they can um, use as a main stocks of their models, from calcitonin and blood calcium up until leptin and appetite in the adipose cells. I know this is not being taught in the sorry, in the basic education, or for those of you who are mga undergraduate students, this is not really being taught before in MSU IIT na parang at this level, na parang med school na siya. But why not give it a try to incorporate this in your lesson plans? So the part one will be, of course, they will find a scientific research paper, a relevant book chapter, or a popular science article. We're doing this in LaSalle. I can remember, if not mistaken, there's a magazine like Science Daily, which I really enjoyed a lot when when authors or journalists laymanize scientific concepts. Tapos it makes the reader to become curious about it, because this is not highly technical terms. So they can find it in Scientific American or any other platforms. Also, they can choose as an encyclopedia article, not Wikipedia. So popular sources like websites, online videos, and blogs. Next is to systems dynamics model. Um, the technicalities of it will be, I will just give you the link because it will take a lot of time. So the models will run according to your descriptions in part 3. And these are the system explanations of the model. You can just choose one, okay? Kasi madaming types of thinking yan eh. So the system thinking, um, yeah, thank you for that. Making, as I go earlier for the previous slide, it makes us, the people who are not liking science to like science, because the jargons are being laymanized, which is we don't really give importance when we introduce these terms, di ba? I can remember if we teach anatomy a human anatomy, where there's a lot of terms, okay? Medical terms. That was, if the students don't get the suffix and the prefix in the root word, they will mess up. Okay, what does this mean? Especially in pronunciation. What I observe in my classroom, especially pag they are not acquainted with the terms, molecular terms, peptidoglycan or polyunsaturated fats whatsoever. And as a person who is really like more critical with how they pronounce the words, I usually correct them immediately. Okay, kasi when they don't hear someone saying it correctly, they would anticipate or they would think that it's the correct way of saying it. Although there are accents, okay, if you notice, like us Filipino have accents, but pronouncing the word correctly and spelling it correctly is uh, uh you know a rote learning in science. But to elucidate the problems or the questions in such a way na you can make it systems. That's a plus. So lastly, in part 4, you complete a reflection form after you have developed your models. And yeah, that's it. Thank you so much.